Hey, so this is Unit 5, Lesson 4, and this is going to introduce a kind of difficult, actually, a difficult area of computer science, which is functions. Now, functions is borrowed from an idea in mathematics, which is if you have an input, it can give you an output. Well, that sounds really complicated, so let's break that down into something much simpler. Say, for example, you have the number 2 and the number 2 can act as your input. So this is the thing you put inside of your magic function. Now the output will do a few things to this input and then give you the output. So for example, if my magic function simply doubles the number, well, if I input 3, then the output would be double the number 3, meaning it would give me 6 back. Now we can apply different types of rules to our function. We can say -3, times 3, divide by 3, divide by 4, times by 1000, divide by 1000. We can do whatever we want. And in this way, we can have a consistent function that does the same thing to each input we give our function. So again, that sounds really complicated. So if we actually use a few examples, I'm sure that you'll be able to understand and you'll be like, oh, teacher, this is so easy. Why didn't you just explain it to me in that way in the first place? So take a look at these functions. You can see the first function is function add 1. Well, it's fairly obvious that all this is going to do is take the input, which is always going to be in this bracket here, and it's going to be x plus 1. So if we have the input, which is 4, meaning x is equal to 4, because x is always equal to the input, and we must plus 1 to x, we do x plus 1, which is actually 4 plus 1, which is then equal to 5. So it's actually 5 here. Great. Next, what is the input? Well, x is the input. And you can see x is equal to 5, so we have 5 here. Now, this is saying that we want to times x by x. So all we do here is do x times x, which is 5 times 5, which is 25. So for here, this would be 25. Now the next thing, we are using letters and words instead of numbers. But the same thing applies, right? So name is our input, and in this case, our input is Lucy. So name is equal to Lucy. And we're going to say hello, name, meaning we are actually saying hello, Lucy. You see how that works? This is the input, and at the bottom here is where I tell you what the actual value for the input is. So in this case, we have Lucy, which is equal to name, and name is the input. Great, let's move on. So here we're going to make our own function, and as you can see, we have an example which is triple. So everything I put into this function is going to triple. Now, I want you to make your own function. It can be something really silly, it can be something really fun, it can be something useful, whatever you want. And for example, I'm going to make something called half. So whatever I put into this function is going to half that input and return a number. So if I put in 1, well, 1 divided by 2 is equal to 0.5. If I put in 2, well, 2 divided by 2 is equal to 1. If I put in 3, 3 divided by 2 is 1.5. If I put in 4, 4 divided by 2 is 2. If I put in 5, 5 divided by 2 is 2.5. If I put in, let's do 8, why not? 8 divided by 2 is equal to 4. So you can see how we can easily apply the same rule to lots of different numbers, and these are all of the inputs right here. And we can get that output right here. So this would be known as x, and this would be known as y. So I want you to make your own rule. And try not to copy mine, try and make yours a little bit unique. And right here you can just say, x divided by 2 in my situation. Or if yours is going to be to double, you can do x times 2. If yours is going to be to, let's say, add 3, you can do x plus 3. So x is representative of all the numbers you'd want to put inside of your function. Or it stands for all of the numbers you want to put inside of your function. Now here, I want you to practice making this table. This table is actually a really important concept in mathematics and calculus, which you guys aren't going to be learning anytime soon, but it's important that you guys know where this leads up to. So all it says is x plus 2. Well, all of these are representative, or these are actually x. So we just plus 2. All we do is we plus 2 each time, and that's how we get the y. I'm not going to do this for you because it's super easy, and I know you guys can plus 2. So later on, what we can actually do is we can actually use this as a way to build specific shapes in a graph. So if we have 0 to 11, we have here from 0 to 20. Well, you can see that 1 on the x column, which is here, and y is here. 1 is equal to 3, so 1 would be maybe here, and then it would be 3 is equal to 5, so 3 would be 5 here, and it kind of make a number, or rather a graph that goes like this over time, right? Because we're reading x is the blue here, and then red would be this point. So this is red, this is blue, so we have x and y. And yeah, you can see the y is always going to be bigger than x, so that's why it's increasing in the y direction much faster than it's increasing in the x direction. If you don't understand that, that's perfectly fine. I know that was very complicated, and you don't actually need to know what I just said, but it's just a little background information so that if you are interested in calculus and functions and mathematics, which I would really love you to be, because it is really such a great subject to learn, and it's really great for your young brains to develop your logic and problem solving skills and determination, resilience and confidence and all that good stuff. So yes, that is the end of today's homework. Much easier than it looks, I assure you, so please don't give up. Remember, I say this every time, but remember, you can do it. I don't want you to think that this looks too hard or to be defeated by this problem, because I know you can do all of the things in this homework assignment. So I'll see you guys in the next lesson. Goodbye.